Hello everyone, this is Akansha from GDSC, and today is our sixth session of this DSA Bootcamp. So, before starting, let me say this one thing that it might happen that you may hear the background noise from my side. So, let me say sorry beforehand. So, without wasting any more time, let's start it. Now, our topic for today is Q. So, first of all, what is Q? If I have to describe in simple words, Q basically means a line of anything. Let's say a line of people, a line of cars. Okay, so in real life, if I have to define what is Q. Q means a line of peoples or anything. Now, similarly, in the programming world, we have Q. Basically, here in programming, we have Q as a data structure. Now, for those who are in second or third year, they might know what is data structure. But for those who are in the first year, let me just simplify what is data structure first. So first of all, data structure means a container. A container, if I have to connect this with from the real life example, let's say that you want to drink water. Now, what utensil you will choose? You will definitely choose a glass. To drink a water, you will choose a glass, not bowl. So similarly, like in case of our households, we use utensil according to the preferences or according to a requirement, we use utensils. Similarly, data structure means container. In programming, we use data structure according to the questions requirement, according to the algorithm. Okay, so here Q is one of the type of container, one of the type of linear data structure. And what does it mean? What does it mean? So Q is a linear data structure which has two ends, one for insertion of elements and other for the deletion of elements. Yesterday we have studied about the stack, and we see in the stack we have only one end, and that same end is performing both insertion and deletion. But in the case of Q, we have two ends, one for the insertion and one for the deletion. Now the second point is it is a homogeneous collection of elements in which new elements are added at one end called the rear end, and the existing elements are deleted from the other end called the front end. Now homogeneous, I've already told you yesterday that homogeneous means same type of elements. So Q basically stores same type of element, and the end from where the deletion is performed is called front end. The end where the deletion is performed is called front end, and the end where we perform the insertion is called rear end. Now, Q are called first in, first out, which basically means the element which is first inserted will be the first one to be removed from the queue. But yesterday we have learned about the stack, that in the case of stack, the element which is last inserted will be the first one to remove. But Q has some opposite. This is the terminology that we use for Q, that it follows the first in, first out, FIFO. I've already told you the reason. Since the first element in the queue will be the last element, will be the first element out of the queue. So here in this case, this is my queue which stores 1, 2, 3, 4, 5. So in this case, my front, which means my front is pointing to 1 and my rear is pointing to 5, which means if I want to add 6, that 6 will be here. And the moment I add 6, my rear will point to 6 now. Okay. And similarly for the front, if I want to delete any element from the queue, then 1 will be the first element to be removed. And the moment I delete 1, my front will point to 2. Now there are basically two operations that we perform in queue. First is insertion and the second one is deletion. And we use some terms for them. Whenever we do insertion, we use a term NQ, and whenever we perform deletion, we use a term DQ. So NQ basically means when we insert an element to the queue, and DQ basically means when we delete an element from the queue. So this is the queue from the last example, this 1, 2, 3, 4, 5. And now here you can see, the moment I delete 1, my front is now pointing to 2. So this operation is called DQ. Similarly, when I'm adding 6 here, the moment I add 6, my real will now point to 6, and this operation is called NQ. So this is basically the illustration of NQ. In the following case, when I have just declared my queue, at that point, when my queue is empty, at that point, my front and rear both are equals to -1. And when I insert A, both my front and my rear, both are pointing to A, and their value is equals to 1. Then I insert B. See, whenever I'm inserting any value, my rear will move forward 1, 2, 3 in that manner. My front will remain at the same place. So here in this case, when I'm inserting B, my front is at the same place, F is equals to 1. It's still pointing to A, but my rear is pointing to B now, and its value is equals to 2. Now when I'm inserting C, you can see in all these examples, my front is at the same place. Only my rear is moving. I'm only incrementing my rear. So when I insert C, my rear will now point to C, and its value is equal to 3. Similarly, when I insert D, my rear end will point to D, and in the case of E also, my rear will point to E now. For the DQ illustration, DQ means the removal of an element from the queue. Now this is the previous example that I have taken earlier. Here in this case, you can understand it from here that when I'm performing NQ, only this R is moving forward. And when I'm performing DQ, my front is moving forward. So when I delete A, my front now will point to B, and my A will be removed. Similarly, when I delete B, my B will be removed, and now my front will point to 3. Okay, so this is how we insert an element to a queue. This code is of C++. So, okay, so here in this function, you can see in this first line, queue string animals. This is how we declared a queue in C++. First we write queue, and then here in the string part, here we write the data type, what type of elements we want to store in our queue. In my case, I'm storing a string type of values. So I'm using a string here, and my queue name is animals. Now at this point, when I've just declared my queue, both my front and rear are equals to -1. And this is how I insert an element. I just use dot push. This is the same way that I have inserted element in stack as well. Yesterday I have shown you the code for the insertion in stack. So similarly, I'm using the same function operation, push operation. So what I'm doing here, this is my queue name, animals.pushCat, which means I've inserted the value cat in my queue. And the moment I inserted cat, both my front and rear, both are pointing to this cat. In the second line, in the third line, I'm adding dog here. So what happens? My rear will now point to dog, but my front will remain at the same place. And the third point, I'm adding animals.pushBear, which means now I'm adding bear in my case. And now my front is still at cat, but my rear will now point to bear. So this is the code for inserting an element to a queue. Similarly, to remove, see, both the operations are same, just like push and pop. These two operations are also the operation that we used in stack also. So both queue and stack are similar in many ways. Just that they just store the elements in a different way. Now, till this line, animals.pushBear, this is how the insertion is performed. My F is pointing to cat and my R is pointing to bear. Now in this line, animals.pop, you can clearly see that I am only giving the data value or the input value in the case of push. But in the case of pop, I'm not giving any input value. So which means whatever my front is pointing to, that value will be deleted. That value will be removed. So in my case, my F is pointing to cat. So in this first line, animals.pop, which means my cat will be removed. So now what happens? Now my F will point to dog here. And the second case, animals.pop, what happens? My front is pointing to dog. So now my front will move forward and it will now point to bear, and the dog will be removed. simple, both the operations are simple. To push an element into queue and to pop an element from the queue. So DQ is another type of queue. It is also a queue, but it is another type of queue. Here what happens, I've already told you in the queue, only one end, only from the one end we perform insertion and from the other end we perform deletion. But in the case of DQ, what happens, both ends, front and rear, both can perform addition and deletion at the same time. You can see in this case, this is my rear end. I can also add an element and I can also remove an element from here. Similarly, from the front end, I can also add an element and I can remove here. See, the DQ, I personally have never used in any of my program, this data structure, but Q I have used many times, but DQ is, I personally have not used DQ much, but you must know what is DQ here. Even though you are not using, just know what does it mean. So basically, that's the theory section. That's the minimum theory that you require before starting before doing any questions in Q. So, Adam, now you can start the topic.
Thank you, Aksha. No, so good evening, everyone. So without any delay, let's jump to the coding section. Let me, Kansha, can you please stop your screen share?
Yes, it is.
Can you please stop your screen? Okay, thank you. So the question one is the array. So problem statement is implement a queue using an array. Queries in the queue are of the following type. Query 1 is 1x, where this query means pushing element x into the queue, and query 2 is 2, which means popping out the element from the queue and printing the popped element. So by example 1 we can see basically we have to implement the pop and the operations of the queue. So let's understand. So as you have seen, queue is a FIFO data structure. The element inserted first will be deleted first. If it is a queue which contains the elements 2, 3, then the element inserted first will be 2 and the element inserted last will be 5. So according to the FIFO property, the element inserted first will be removed first. So 2 will be removed first, then 3 will be removed, and similarly 4 and 5. So this is the FIFO property. Now we want to implement the push operation of the queue. So simply idea is to insert the every new element at the back of the array. What I am thinking is, if we want to suppose the array is 2, 3, 4, and we want to push 7 in this array or 7 in this queue. So the idea was to simply insert every new element at the back of array. So the back of the array is this, so simply insert 7 at this position. We can implement this function using 2 pointers. The first pointer is front. Front means this pointer will point to the first element of the array. First element of the array is this. So first will point to this position. And the second pointer is back. And this back pointer will point to the last element of the array. And the last position or the last element in the array is 7. So back will point at this position. Suppose the configuration of Q is this, and we want to insert the new 7 in this queue. So initially front is pointing to this position and back is pointing to this position. As we have seen, we are inserting the new element at the back of array. So increment the back pointer. Now back is pointing to this position and simply insert this 7 at this index. Push operation of the queue. So let's try to code it. Push operation. So what we were doing is we were inserting the new element at the back of array. So rear is pointing to the back of array and front is pointing to the array. Simply so we store our new element x at the back of array, and now after inserting the new element, increment the rear pointer so that it will point to the next empty position at. So we are done with our push operation. In this queue 2, 3, 4 and 7 are to this position and back is pointing to this position. So as we have seen in the FIFA functionality, the element insert first will be removed first. So we will remove the element from the front of the array. First we will remove 2, then increment the first pointer, then increment the first pointer, remove 4, increment the first pointer. So remove this front of the array. And after the element, what we are doing is we are incrementing the front pointer by 1 each time. So increment, but there can be a also
Agam, your voice is breaking.
Am I audible now?
Yeah, go.
Okay. So I was telling there can be a case when there is only one element in the queue. In this case, front is pointing to this position and back is also pointing to this position. So if we delete 7 from the queue, our first will point to this. It will be out of bound. So to handle this case, front become equal to rear pointer, then we can reset our front and rear pointer to 0. Equals to 0. And there can also be a case where our queue is empty. So to handle this case, we can apply a condition. If this condition is true, then our queue will be empty. So in case of empty, return -1. Let's try to run it. Correct answer. Let's try to submit it. Sorry. We also have to set the pop. So the pop element was element A. Let's try. Let's try to submit it. So it is running fine. If you have any doubt, you can ask in the chat section in this particular question. No doubts. All right, let's move to the second question. The second question is stack using two queues. So we have to implement a stack using two queues, Q1 and Q2. Two operation push and pop. So we want to replicate the LIFO functionality with the help of two queues. Let's see what is LIFO and what is stack first. List, which means the element will be popped out first. So this is one thing to observe here is all operations, which means push and pop operation at the one end only, and in the FIFO functionality, which is we were inserting the element at the one end, push operation, now the element from the another end. So this is FIFO functionality, and create this functionality queues. So every new element subject, it is always ready, and we can achieve this functionality with the help of another. So far we have seen LIFO functionality and FIFO functionality. Now, how we can push a element in a LIFO fashion two queues. So first take two queues, Q1 and Q2. So what I'm thinking, such that it is always at the front of, let's say at the front of Q1, and we can achieve this functionality with the help of another queue, which is Q2. So let the configuration is like this. This is Q1. It contains element 2, 3 and Q2, which is initially empty. So for push operation, step 1 will be, let's say we want to insert 4. So step 1 is insert this 4 element to Q2. Insert new element. So insert 4. Now step 2 is move all the elements of Q1 from Q1 to Q2, which basically we are moving everything from Q1 to Q2. So front is pointing to 2. So pop out 2 from, push it into Q2. Now it is pointing to 3. Remove 3 and push Q2. Step 3 is again move everything from Q1. So step everything from Q2 to Q. Our Q1 is empty and Q2 contains these elements 4, 2 and 3. So pop out 4 from Q2 and insert it in Q1. Then pop out 2, insert it in Q1. Then pop out 3 and insert it in 3. Insert it in Q1. So these three steps will ensure that the last inserted element, and the last inserted element was 4, is at the front of Q1. So let's try to implement it. So we are provided with two queues, Q1 and Q2. So step 1 is insert new element to Q2. So Q2 dot push X. And step 2 is move everything from Q1 to Q2. While Q1 is not empty, take out element from Q1 and insert the fourth element into Q1. So we are done with. Now step 3 was again move everything from Q1 from Q2 to. So while Q2 is not empty, take out the front element from Q2 and insert it Q1. So Q1 dot push this element. So our operation in LIFO fashion is implemented by these three steps. Now see what is pop operation. So in stack or in LIFO, the element inserted last will be removed first. Suppose we inserted 4 at the last. So according to LIFO property, the element removed will be 4. And during insertion or during the push operation, we ensure that the last element is always at the front of Q1. So to remove the last element, we can simply pop the front element from the Q1. So what I am saying is last element is front of Q1. Q1 dot pop. But there can be a case when both the queues Q1 and Q2 are empty. So to handle the case, we can apply a check. If Q1 is empty, we can return -1. So let's try to run it. It is running fine. So it is giving us correct answer. Now, if you have any doubt, you can ask in any of the question. If you have doubt, you can ask in the chat.